So in today's class, I'm going to just show you the demonstration how switch and hub are going to have any data transmission is going to be there. So apart from that, we'll also be saying that how a collision carrier sense multiple access is going to have a detection when it comes with the help of your switch or an hub. So to go through all these things, let me take up a end devices as a PC. I'm just considering five. I'm just taking up a 5 PCs. So already I placed two, the third one, fourth one, and fifth one. So simultaneously, I'm going to have another 5 more PCs are there. So this PC I'll be using it for when it comes for a simulation with respect to a switch. I'm just placing all these things. And now let me choose a interface device in the form of a hub and just placing it up for the section number 1. At the same time, let me choose a switch as an interface device. So now what I'm going to do is that, so let me connect the devices with respect to the hub. And as soon as we are going to place a connection, you can see that there will be two upside down arrow mark will be there. It will be there in the green color. So once if it is turned into green, it indicates that the ports are in live condition, so that whatever the data I'm going to transmit, they'll be keep on going for a transmission. And let me connect this first switch also. I've just made up my switches also. So since the connections are over, the next part what we have to see is assigning of a logical addresses. So let me take up a logical assigned IP address. To assign the logical IP address, click on the PC and then click on the desktop and then click on IP configuration. So where you will be getting up a IP address static, by default it will be stored as a static IP address. So when it comes for assigning of an IP address, there are varieties of classes as we have seen. We have a class A, we have a class B, and we have a class C. See, out of these three, any sort of a classes we can make up an assignment, but the cache should be taken in such a way that the assigning IP address should be of a same network. It should not have a different network. So be careful while assigning your an IP address. We should not have a different network address. We should have a common network address. Okay. For a hub, let me choose class B address. I'm just making it up 178.168.10.1. And for a 16, I'm just giving the same sort of an IP address. What does I have followed here? 172.168.10.2. And then for a third PC, 172.168.10.3. And then for fourth one, 172.168.10.4. And for the fifth one, see 172.168.10.5. And similarly configure this for switch connections also. So the same procedure which I'm going to take it up. Let me have the same sort of 172.168.10.1. So 172.168.10.2. One 172.168.10.3. One 172.168.10.4. And the last one, 172.168.10.5. Okay. Now we have assigned an IP address. So we have configured logically. See, what we are going to do right now is we'll focus on the transmission with the help of a hub. See, one of the major thing what hub will do is that, so whenever hub receives a packet, it broadcasts to all the nodes which have been connected. For example, if PC19 is sending a data, once the data or a packet reaches the hub, it will broadcast to PC15, also PC16, also to PC17, also to PC18. So this is a problem which we had in a hub. Wherever the data are going to be there, whatever the data the hub is going to reach, it is going to broadcast to everything. So it depends on the network individuality that whether if the packet is not meant for you, you can drop it up. Sometimes you cannot assume, you cannot be more trustworthy. Sometimes I may be reading the packets which I've received out of a curiosity. This is a problem which we'll be facing in a hub. So to demonstrate that how the transmission is going to happen, let me choose a protocol data unit. Let me choose a PDU. I'm fixing it up 19 and I'm just ending it up 60. See, as soon as I'm going to place up these two, you can find that there is a type of protocol which I'm going to have is an ARP. So before this, just click on the edit filter, make sure that we have only ARP is selected and then close it up. Now, before going to have a simulation to see how the transmission is works, let me check whether the PC19 have the ARP of PC16. See, the command ARP is the one which gives you an address, is nothing but an address resolution protocol which fetches you the MAC address of the destination. See, without the MAC address of a destination, it is impossible for you to go for transmission of a data. So only for that I'm using ARP. Let me check up ARP A. It found that there is no ARP entries is not there. Okay. Now we'll go for a simulation. I'm just passing the packet here. And you can find that the packet reaches to the switch or the packet reaches to the hub. So once it reaches a hub, so it broadcasts to all the devices here. You can see that here it broadcasted to all the devices. So what is the change we are noting down here is the PC15, PC17 and PC18 is the one where you find that the red mark will be there. It means that the packet delivered to that particular nodes are not meant for them. But whereas you can see the difference when it comes for a PC16 is that the packet, it doesn't have any, the packet doesn't have any sort of a cross mark. It means that originally the destination is PC16. So once the transmission is completed, then what I'm supposed to check it right now is I have to update my ARP. So you can find that when I'm going for an updation, the transmission will take place only from PC16, whereas other PCs with the connected to that particular hub will not be giving any sort of response. And so once it reaches to the hub, as usual, the hub will be keep on delivering the package which has received to all the nodes. The same scenarios will be obtained here, where you can find that other PCs will be have a cross mark, whereas the PC19 will have a tick mark. It understood that the packet which is meant for 19 is arrived, and hence my transmission is completed successfully. So now our ultimate aim is that to check whether the ARP table is updated in PC19. So once again, go to desktop, choose a command prompt and type ARP space -A, and you can find that the ARP table has been updated here. Clear? Now we'll see how collision is going to happen, what is the impact of collision here. So to check that, I'm just resetting my simulation and I'm just placing the protocol data unit from PC 9 to 16 as well as PC 9. Okay, I place my data unit. In that, what I'm going to do is right now go to command prompt and delete the ARP table. So to delete ARP table, the command which I'm going to employ is ARP space -d, and I'm just checking it up whether the table is there or not. You can find that there will not be any sort of a table is there. So now pass the message. And once if the message is passed, you can find that the systems which are connected here when the hub might have received all the packets with a firing symbol will be there. So this symbol indicates that the collision has occurred. So to elaborate or to make up a little bit of a fighting nature, the firing symbol has been used to indicate a collision has occurred. So once if this situation has happened, what the PCs will do is that there is a algorithm is there in the form of a backoff algorithm. That algorithm will be used here. So once if I'm going to employ that algorithm, what I'll be doing is that I'll be generating some sort of a time and that I'll be passing it to all the nodes. So what I mean a node is all the PCs which I've connected here. See, once if the node catches the time or the node receives the time to share the medium. So here question will rise, all the nodes have had a time, how the mediums are going to be shared now. The node which possesses the minimum time will be given a priority to access the medium. So this is how the transmission will take place, and this is how we can avoid a collision in terms of an hub. So what I'm going to do is that, so continue my transmission by reassigning the timing situation here.